Okay, welcome back. We're going to finish up the chapter by talking about one last section. It's called Describing Motion with Diagrams. And hopefully this will be an easy thing for everyone to learn. Hopefully it makes sense to you guys. So, ticker tape diagrams. In the guided notes, be following along in your guided notes, you're supposed to write the definition for a ticker tape diagram. And so, let's go over that definition real fast. Ticker tape diagram uses dots to track the motion of an object at specific time intervals. So it uses a dot at specific time intervals to kind of track its motion. So for example, there could be one dot every 5 seconds, or it could be one dot every 10 seconds, but what's consistent is this time interval. Okay? And so we can get a lot from these diagrams just by looking at them. Okay, so the dots show the history of the object's motion. If you look at a motion diagram, the dots show the history of that object's motion. Ticker tape diagrams can show a couple of things: velocity, and it can also show acceleration. So at the bottom of this slide, I'm just going to number these. These are the examples of motion diagrams. Some people call them ticker tape diagrams, and some people even call them oil drip diagrams. If you think about a car and it has an oil drip, so that there's this oil that's leaking out of the bottom of the car at specific time intervals. Well, it would drop an oil spot there, here. And so there's a number of ways you can think about these things. But anyway, let's look at this first one, guys. How would you describe the motion of that object, Riley?
Staying the same.
Staying the same what?
Speed.
Constant then? Constant velocity? Exactly right. How do you know it's constant velocity? Put it into words. I know you know it, but you're right. But tell me why.
Because they're all like the same distance apart.
Good. The dots are all the same distance apart. All the way across this, they're the same distance apart. That tells you that the car had to be going at a constant velocity. Very good. Okay, let's look at the second one down. Notice what's happening here, guys. As you move across, let's pretend that this object is moving to the right. What's happening, Wyatt?
It's accelerating.
It's accelerating. Good. How do you know that?
The dots grow farther apart.
Good. The dots at the beginning were close. At the end, they're farther apart. Dawson back there. Let's look at number 3. Explain to me the motion of that object in number 3.
Speeding up.
Speeding up. Good job. Another way of saying that is what? Accelerating. Excellent. Now, which one? Now, 2 and 3 are both accelerating. Which one is accelerating at a faster rate?
3.
Number 3. How do we know that? Yeah, they start closer together on 3, but look at the end, they're farther apart. So number 3 is accelerating at a faster rate. Good job. Okay, the distance between the dots represents change in position for that time interval. So that means a couple of things. Number 1, large distances between dots indicate that the object was moving fast. So if there's large distances between the dots, the object's going fast. Smaller distances between the dots indicates that the object is moving slower. Okay, so here's a couple of examples. If we look at the dots here, large distance compared to this bottom one, there's a larger distance, so this one's going fast. Down in the bottom, small distance between the dots, it's going slower. Okay, I think we can see that. Ticker tape diagrams also reveal whether an object is moving with constant velocity or accelerating. A changing distance between dots represents changing velocity or acceleration. So if there's changing distance between the dots, you're going to have acceleration. Now, if the dots are spread out equally, then the object had a constant velocity. Okay, so if they're spread out equally, it's constant velocity. And that's what these examples at the bottom is showing you. Constant speed, well, you notice that the distance between the dots is constant. So it's going at a constant speed. This one's accelerating. So we see that it starts off small distance, ends large distance. We can see that. This one, lots of acceleration because we started very close. At the end, the car must have been speeding up a lot because it's a lot of distance between them. Okay, I've got 4 practice problems to kind of see if we understand this. So let's go through it. I'm going to call on random people. If you're watching the video, I would pause the video before we go over the answer to see if you can get the answer before we do. Okay, it says on number 18, describe the motion of the following ticker tape diagram. I want to point out a couple things. This object is going to the right. So that means this is the start, and this is the end point. Okay? So, let's call on Brandon back there. How would you describe the motion of this ticker tape diagram?
Speeding up.
Speeding up. Another way of saying that is what? It's accelerating. How do you know that? We're slowly getting farther apart. We start out very close distance. We end with farther distance. Okay, good job. It's accelerating. So the answer to that, I would just put accelerating. Okay, number 19. It says, describe the motion of the following ticker tape diagram. Again, it's going to the right, so this is the start. And the other side is the end. Okay. Let's go to Clint. Clint, how would you describe the motion of this object?
That's decelerating.
Decelerating. Well said. How do you know that, though?
Because the dots are getting closer together.
They're getting closer together. Yeah, it was going fast here, wasn't it? But then as it progressed through its motion, at the end it was going very slow. So it's decelerating. Good job. The answer to number 19 would be decelerating. Okay, number 20's got 3 parts to it, A, B, and C. It says, describe the motion of the following ticker tape diagrams. So Gabe, how would you describe the motion of A? Constant speed or constant velocity. How do you know that? You're right. Good. Yeah, the distance between these dots is consistent. No change. It's going the same speed. Good job. Let's go Justin back there. What would you say or describe the motion of B?
Accelerating.
Accelerating. Right. How do you know?
Because they're getting farther apart.
The dots are getting farther apart. Okay, good job. If you compare the start to the end, they're getting farther apart at the end, so that means it's accelerating. Good job. All right, and finally, Steve, part C, how would you describe it?
It's slowly accelerating. You were at a standstill and you've increased your rate of acceleration.
Okay, so it is accelerating. Good job. So the answer to C is accelerating. Now, if I asked you guys to compare B and C, which one's accelerating faster? C is accelerating faster. It was almost no motion right here. Those dots are very close together. At the end, they were much farther apart. So C has greater acceleration. Good job. Okay, I think is this the last practice problem, guys? Okay. Practice problem number 21, it says, draw a ticker tape diagram for the following scenarios. So if you're watching the video, pause it after each one of these. There's A, B, and C, and draw them before you watch the answer. Okay, on part A, a car is moving at constant speed, then slows down quickly. So I want you to draw that with a ticker tape diagram. Okay? So a car is, how do we show constant speed, guys? Yeah, equal distance apart between all these dots. So those first 4 dots, hopefully they're close. That's constant speed. Equal distance between them. Now we want to show that it slows down quickly. How would we show that? Yeah, we need to get them closer together. And so it slows down quickly, so it comes to almost a stop very quickly. So to about right here, that's constant speed. And then from here, it decelerates very quickly. Something like that. Hopefully you drew something like that. Okay, part B. A car is accelerating, then sees a deer, hits its brakes until he stops. Okay. How do we show acceleration? Because the first part of this, he's accelerating. Yeah, so we start kind of slower, but then we get bigger and bigger apart. Okay, so there's our accelerating part. He sees a deer and hits his brakes and stops. Okay, so let's say he sees the deer at this point. This is where he sees the deer. So then he's going to slam on his brakes. These dots are going to get very close together. And how would you show stopped? Just a bunch of dots on top of each other, like that. Okay, so again, this line that I drew, you don't have to draw that, but that's just where he saw the deer. Okay, finally, part C. A car is decelerating, then moves at a constant speed, then speeds up. Okay, so we got three things going on here. So how do we show decelerating? Yeah, they're getting closer together. So he's decelerating here to that point. Okay. Then moves at a constant speed. So let's show constant speed for a second. Okay. And then he speeds up. How would I show speeding up? Farther apart. Yeah, so now it's farther apart. Okay, so hopefully ticker tape diagrams or motion diagrams make sense to you. Hopefully that helped.